Good morning and welcome to today's demonstration of the CARMAS tool for the C4IoT project. What we have on screen here at the very left is CARMAS initialization file, which basically controls how it is mounted as a web server. In this case, it is created as a non-interactive daemon, as is usually done with most web servers, and listening on port 8080 as shown in the file. The file on the right is the Docker file that controls how we will build the image corresponding to CARMAS. Now, we have defined a make command that allows us to build CARMAS, so let's proceed and do that. As you can see here, we have successfully built and tagged our latest version of the CARMAS tool, which we will use immediately in the demonstration of the tool. So, in this new window, as you can see, we have 6 different portions. At the top, we have 3 files, which I will introduce shortly, and on the bottom we have three terminals with which we will proceed with the demonstration. So at the top left, we have the definition of a very simple HTTP client in Prolog, which will serve to mock the client functionalities of Edge's AVT tool. On the right, we have a very similar initialization script for a server that behaves similar to CARMAS, but here all it does is output whatever it receives as a JSON payload to a log file, which in essence will show us if CARMAS has successfully sent a reply back after processing the attack plan it receives. So, as you can see, we have a simple definition of an attack plan based on the current detection capabilities of the tools, and then we simply transform it to JSON and send it out to CARMAS for processing. And then we simply write out what CARMAS replies once it receives the plan. All of this is orchestrated with the use of Docker Compose. With Docker Compose, we expose 3 services that will be used for this demonstration. First, we have CARMAS, which will use the image we have just built. We have the AVT server stub, which will correspond to a Docker image, which contains the code to run the AVT server that is here on the right. And then we have the AVT client stub, which will do something very similar, but instead we'll use a Docker container containing the information on the left. So with this definition, let us now build and compose our 3 services, and then observe how it responds. So now we see that the AVT client stub is waiting for CARMAS to be available, and now that it has first output the JSON that it will send, and then it has output the JSON that it has received from CARMAS. Now, CARMAS itself has shown that it has received the post request and has received an attack plan, and then that it has also tried to reply to the AVT server stub. So let us now confirm that this has actually happened. We will now use the docker compose exec command to run a bash shell on CARMAS and output to this terminal whatever is contained in the HTTP log file of CARMAS. If we do so, we will now observe that CARMAS has effectively received a post request and has interpreted the different attack types that are within. It has created the problem, the constraint satisfaction problem that it has to solve, and it has then presented the solution and sent it to the AVT server stub. Right here on the right, we will now do something very similar, but instead of doing it on CARMAS, we're going to do it on the AVT server stub that we have defined here on the right. It also has a log file, and then we should see within, as we effectively do, that it receives a mitigation plan as a post request, and the information contained is right here, which corresponds to what CARMAS has found here, right in the middle. This then allows us to conclude our demonstration of the CARMAS tool for month 18. Thank you very much for your attention.